Welcome back to geometry class. This is the class for Tuesday, the 25th of March. Glory be to the Father, to the Son, and the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. Okay. The objective today is to solve a 30, 60, 90 triangle, but first let us review the 45, 45, 90 triangle, which is the one you just turned homework in this morning by 8 o'clock. The solution is posted now in Blackboard on your class notes, but let's just review theorem 8.8. It simply says that if you have a 45, 45, 90 triangle, the hypotenuse is the square root of 2 times larger than either one of the legs. So if I take one and I multiply it by the square root of 2, I get the hypotenuse. So in one problem, you may have been given a leg and asked to find the hypotenuse. You know the other leg is 5, because it's isosceles. I could use the Pythagorean theorem, but theorem 8.8 is a shortcut that says all I have to do is take 5, multiply it by the square root of 2, and I get my answer. The other type problem was a little more difficult. It was given the hypotenuse, how can you get the side that would have produced that hypotenuse? Well, I used the same theorem. I know that this leg x multiplied by the square root of 2 has to give me the hypotenuse, which is 4. So x times the square root of 2 is 4, or a leg times the square root of 2 is the hypotenuse. If I divide both sides by the square root of 2, I get x is equal to 4 divided by the square root of 2. The other thing you might notice is if you have to multiply by the square root of 2 to get from here to here, if you're here and you want to get back to here, all you have to do is the opposite operation. The opposite of multiplying by the square root of 2 would be dividing by the square root of 2. So you could go right to the answer. Okay. But remember, this is not how we express radicals. There cannot be a radical in the denominator. We have to multiply by a special form of 1, square root of 2 over 2. What we get is we get 4 square root of 2 over square root of 2 times the square root of 2 is the square root of 4, which is 2. However, 4 over 2 cancels to 2. So here is my final answer. For homework, and especially for a quiz that you may have upcoming, you want to make sure you show your simplification to get full credit for the problem. You have to show how you get this far, and then you have to show how you simplify it to get the final answer. You must put the final answer in simplified form and show all your steps on how you got to your final answer to get full credit. That's very important. So now let's take a look at the 30, 60, 90 degree triangle. Okay, here I have a 30, 60, 90 triangle because it has a 30, 60, and 90 degree angle. We know one side. This side, it's the name of this side is the hypotenuse. Okay. These two sides are not the same like they were in the 45, 45, 90 degree triangle. They're going to have special names that we have to understand or know to understand this section. This side we will simply call the short side or short leg. This side we will actually call the long side or the long leg. It may be confusing, but the long leg is not the longest side of the triangle. Okay, that can be confusing. I have 2 legs and a hypotenuse. Since my 2 legs are not the same length, I call one the short leg and one the long leg. And that nomenclature is very important because we'll use that throughout the chapter. Now that we know how to name the sides of a 30, 60, 90, let's see how we find the side ratios. This is not a 30, 60, 90 triangle. This is isosceles. Okay? This triangle is equilateral. Okay? Since it's equilateral, we know the angles have to be 60, 60, and this one up here is also 60. Now, if I was to take a perpendicular line, otherwise known as an altitude, of this triangle, and this is 90 degrees, I would find that this triangle right here and this one over here are congruent. They are, in fact, all the sides and angles are the same. If that's true, this is a midpoint, which means that from here to here is 1 unit long, from here to here is 1 unit long. So now what I'd like you to look at is just this right-hand triangle right here. This says that if I have a triangle with a 60 and a 90, well, what does this one up here have to be? It was originally a 60 and it was cut in half. So this is a 30. Sure enough, 30, 60, and 90 add up to 180. So this is a 30, 60, 90 triangle. What I see is that the short leg is always half the hypotenuse. That will always be true in a 30, 60, 90 triangle. And I can actually get this leg over here, because if I call this x, I know that x squared plus my other side, 1 squared, has to equal my hypotenuse squared. So that means that x squared plus 1 equals 4, x squared equals 3, or x is the square root of 3. So I now know that this side is the square root of 3, and I now have my ratios for any 30, 60, 90 triangle. If the short leg is 1, the hypotenuse will always be twice that length, and the long leg will be square to 3 times that length. These ratios are important, and that's how we're going to be able to solve problems for 30, 60, 90 degree triangles. So here's my 30, 60, 90 degree triangle. I know that the short leg is half the hypotenuse, and if I take the short leg and multiply it by the square root of 3, I get the long leg. You do not have to memorize this relationship. It is given to you in Theorem 8.9. The confusing part is understanding how the theorem is presenting the information to you. It states that the ratio of the short side to the hypotenuse to the length is 1 to 2 to 3. So that's saying if the short side is 1, the short side is 1, the hypotenuse is second, it corresponds to the 2, the hypotenuse is 2, and the long leg is the square root of 3. And notice it's saying this is a ratio. So the short leg to the hypotenuse to the long leg is in the ratio 1 to 2 to square root of 3. And we know that all other 30, 60, 90 degree triangles are similar to this one. Okay? So you either have to memorize this or know how to apply the theorem to draw this. And once you know this, problems aren't that bad to solve. The key is to find the short leg first. Because hopefully in this problem, since we know the short leg, you'll see how to do this problem, and then every other problem, you just have to find this first, and it won't be that hard. First, I have to convince myself that this is a 30, 60, 90 degree triangle. If this is 90 and this is 30, that adds up to 120. The other angle has to be 60 to get to 180. So I do have a 30, 60, 90 triangle. I know the short leg. What do I do to the short leg to get to the hypotenuse? I double it. What is 4 square root of 3 doubled? That's like having 4 apples. I now have 8 apples. I now have 8 square roots of 3. So that wasn't that difficult. If I know the short leg, what do I do to get the long leg? I multiply it by the square root of 3. What is 4 radical 3 times the square root of 3? Well, I know the square root of 3 times the square root of 3 is 3, because that's the definition of a square root. Times 4 is 12. So when you know the short side, the problems are not that difficult. Double it to get the hypotenuse, multiply by the square root of 3 to get the long leg. And if you did the Pythagorean check on this, this squared plus this squared, you would get the hypotenuse squared. It's a good way to check your work. So finding the short leg first. If you know the short leg, it's easy to solve the problem. We're going to have to find the short leg first in this next example. In this example, I have a 30, 60, 90-degree triangle, but I do not know the short leg. What I know is the long leg. I know the long leg is 6. Now I have to find the short leg and the hypotenuse. I'm going to follow the guidance of finding the short leg first. If I knew the short leg, what would I have to do to it to get the long leg? If I knew the short leg, I'd have to multiply by the square root of 3 to get to the long leg. So if I know the long leg and I want to get back to the short leg, all I really need to do is take 6 and divide by the square root of 3. I have a radical in the denominator. I'm going to get that out of the denominator by multiplying it by the square root of 3 over the square root of 3. Okay, what I get now is square root of 3 times the square root of 3 is 3. 3 into 6 is 2. So this is 2 square root of 3. Notice in the 30, 60, 90-degree triangle, radical 3 shows up. That's different than with 45, 45, 90-degree triangles. We were using radical 2. Square root of 2 is used for 45-degree triangles. Radical 3 is used for 30, 60, 90-degree triangles. Don't get those two mixed up. It's easy to do. Remember, it's right there on your theorem sheet if you need to check to make sure you're using the right radical. All right, now I have the short side. The short side is 2 square root of 3. If I know the short side, what do I have to do to get the hypotenuse? That's easy. All I have to do is double it. 2 square roots of 3 doubled is 4 square root of 3's. Okay, so I now have the 3 sides. I have solved this triangle because I know all the angles and I know all the sides. Let's check our work real quick. If this is in fact true, this is my hypotenuse. I know that a squared plus b squared is c squared. Let's just check to make sure that's true. Is 6 squared plus 2 radical 3 squared equal to 4 radical 3 squared? Well, I know 6 squared is 36. What is 2 radical 3 times 2 radical 3? 2 radical 3 times 2 radical 3 is the same as 2 times 2 times radical 3 times radical 3. 2 times 2 is 4. This is 3. So 4 times 3 is 12. I'm sorry. Yeah. Now I need to do the same thing for 4 radical 3. I know that 4 radical 3 squared is going to be same as 4 times the square root of 3 times the square root of 3. 4 times 4 is 16 times 3 is 48. 48. Sure enough, 36 plus 12 is 48. Like I said, that's a good way to check your work, because if the Pythagorean theorem works on this, you know you have the correct answer. Okay, and that's a good way to check your work. Let's do one more example just to make sure we understand all the options of how a problem might be presented to you. For our last example today, again, we have the 30, 60, 90-degree triangle, only this time I know the hypotenuse. The hypotenuse is 10. Well, I know that if I follow my key here and find the short leg first, it'll make life a lot easier for me. So if I know the hypotenuse, if I want to find the short leg, what do? I just take half of it. Half of 10 is 5. And if I know the short leg, what do I do to get to the long leg? I just multiply it by the square root of 3, not the square root of 2. Square root of 2 belongs to the 45, 45, 90. And I have solved this triangle. I know all the sides and I know all the angles. So to get some additional practice, your homework is going to be the rest of the problems on page 101, problems 9 through 16. I want you to show your work, especially simplifying radicals. One of the things I'd like to find out from your homework for tomorrow is that you know how to properly simplify radicals. Okay, that's getting the radical out of the denominator like we did the example before. Right? So there's your homework. I do have a couple extra problems for the honors class. So if you're in the honors class, hang on for a minute. If you're in the regular class and you're going to the honors class, I invite you to watch these problems as well. And if you're in the regular class and you're bored at home, you want some extra problems, hang around for a minute. All right, welcome everybody back to the honors class and those who decided to stick around for a few minutes. I have two examples I'd like you to work through and then we'll do them on the board. I left this up since this is relatively new. Use that as a guide. Keep in mind, this is not a 30, 60, 90 degree triangle. This one is the 45, 45, 90. What I want you to do in this problem is, given the hypotenuse, find x and y. This is a 30, 60, 90, because if this is 30 and 90, you can figure out that one. So if this is the square root of 15, find z and w. All right, so take a few minutes and try to figure out all four of those missing variables to solve both triangles. We'll review that in just a moment, whenever you're ready. Let's solve the first one, top one first. This is a 45, 45, 90. Do not make the mistake of applying these ratios to this problem. What do we know about a 45, 45, 90? One leg times the square root of 2, not the square root of 3, gives you the hypotenuse. So if you know the hypotenuse and you're going back to find the leg, I need to take 2 times the square root of 3 and divide by the square root of 2, not the square root of 3. The square root of 3 belongs to these type problems. Again, I have a square root of 2 in the denominator. I don't like that. I multiply by the square root of 2 over the square root of 2, and I get x is equal to 2 times the square root of 6 all over 2. But notice my 2's cancel, so I'm left with x is the square root of 6. Since it is isosceles, this is also what y is equal to. So x and y are the same, the square root of 6. I could check this problem by using the Pythagorean theorem. Square root of 6 times the square root of 6 is 6, plus the square root of 6 times the square root of 6 is 6. The square root of 2 times the square root of 3 is 2 times 2 is 4, times 3 is 12. It does, in fact, check, or the Pythagorean theorem conditions are met. All right, let's go to this problem. In this one, I have a missing angle here, so I'm going to solve it completely. I need to find that angle is 60. It is a 30, 60, 90 degree triangle. It is similar to this one. I now know even though it's oriented differently, this is the short side, because the short side is always across from the smallest angle. Smallest angle is the 30 degree. If it's the short side, the hypotenuse is simply 2 times the short side. So now I know that z is equal to 2 times the square root of 15. Okay? And if I want to find w, I know that the long side, this is the long leg is across from the 60. This is the hypotenuse. The hypotenuse is always the longest leg. This is the longest, I'm sorry. The hypotenuse is always the longest side. The long leg is always across from the 60. So w, the long leg, is a square root of 3 times bigger than the short side. So I know that this is 3, square root of 3 times bigger than the square root of 15. However, if I notice that 15 can be factored into 3 and 5, so I really have a perfect square that I can factor out. Okay? And if I factor this perfect square out, I get 3 times the square root of 3 as my final answer for w, and z. I erase that. Simply double this one is 2 times the square root of 15. So the final answer for w is 3 times the square root of 5. Okay, that's the final answer you should be able to get to in simplified form. Okay, make sure you understand the steps If you have square root of 3 times the square root of 15, you could have also written that as the square root of 45, and then realize that 45 is just 9 times 5, and you can take the square root of 9, which is 3. Okay? So you need to be able to get all the way to an answer like this for these type problems. Okay, so just a couple of additional problems that were a little bit harder. Hopefully you made out okay on those. You have your homework. Have a good day, and we'll see you tomorrow.